Hello, everyone. Thank you for tuning in to our webinar today on how to minimize data replication lag in PostgreSQL. I'm Annie, your host, and today I have with me Umair Shahid, founder of Stormatics, as the speaker of this session. So before we dive right into it, I would like to share the usual housekeeping items. The recording of the webinar will be shared afterwards, so feel free to use the Q&A feature throughout the session to ask the questions related to the session, and we'll get back to you at the end of it. And that's all from my end. Over to Umair.
All right. Thank you, Annie. I noticed that people were joining in as you were saying those housekeeping items, and maybe somewhere in the middle we can repeat those for people who weren't able to hear them. But welcome everybody who is listening in right now. We are going to talk about replication lag in Postgres and how to minimize it. This is part of the webinar series that we conduct at Stormatics, where we share our knowledge and our experience in customer production databases. And let's move on. If only I knew how to click forward. There you go. Okay, so the topics that we're going to cover today are, well, we're going to start off with an introduction of what data replication is, the types of replication that are available with Postgres, and the key factors that will impact replication latency when you set up a cluster. A case study that showcases improvement that you can achieve by tweaking a few key areas. Some best practices, and then we are going to conclude this talk, this webinar. So first up, introduction to data replication. Now, what is data replication? It is defined as the process of copying and maintaining objects and data across multiple servers. As the diagram over here shows, you've got a primary server right here that the application is writing to, and data gets replicated or copied to these two servers right here. And this process of copying data over from the primary server to the standby server right here, that's what's called replication. And the architectures for data replication, you can have multiple architectures. It could be co-located, so there could be, these nodes could actually be in the same building, in the same data center. It could be, these nodes could be across data centers. They could be in different regions of the country or the continent, or they could also be across multiple continents. So the concept remains the same, and the architectures vary. Now, why is data replication important? Well, one thing is obvious: you cannot set up a database cluster without using replication. But some key points to note: there is data redundancy that's achieved, so it protects you against data loss in the event of failure. You can improve performance by two major means. One is you replicate data close to the region where your end users are, so they get lower latency, and their user experience becomes better. And the second is load balancing, and that's what's depicted in the diagram right here that you see on the right. So in the previous slide, we had the application talking to both read and write with the primary server right here. But in this architecture, the writes are taking place to, with the primary server, the application writes to the primary, but the reads are coming in from the standby right here. So the load of these read queries are taken up by the standby one. And in case you want to run reporting or analytics or business intelligence, that is being done over here. and the standby 2 takes care of that kind of stuff. So essentially, by distributing the load across 3 different nodes, you get the ability to improve the performance of the entire cluster. Also, replication enables high availability, and you can implement failover to create a fault-tolerant system, and you get the ability to recover from disasters in case of a catastrophic event, let's say a data center failure or a flood or an earthquake or something. If you are distributed across regions, you can very quickly recover from those kind of disasters, and all that is achievable only via data replication. Okay, what is exactly is auto failover and how you achieve high availability? This series of diagrams represent exactly how that happens. So right over here, you see that for whatever reason this node crashes, this node goes down, and the cluster detects that the primary has gone down and application no longer has a database to talk to. What the cluster does is it promotes the standby to become the new primary. It removes the old primary from the cluster, and this previously standby 1 becomes the new primary, and the application can start talking to this new primary. So essentially, this entire failover process ensures that you can very quickly recover from a disaster, and that the database remains available to your application, even in the case of disaster. Now, as you create those clusters and as you replicate across geographies, there are some implications that I wanted to highlight. There is the physical distance as it increases, it creates some challenges. And the biggest of those challenges is latency. Because the data packets need to travel longer distances, and those data packets cannot travel faster than the speed of light. It takes time to go from one place to the other, and that creates the lag or the latency. And as they go through multiple continents or across multiple countries, these data packets potentially